Welcome everyone to our teaching series. Today we'll be starting with the topic set, the SSCE aspect of it. Set is a collection of objects. Object here means numbers, things, places, etc. Generally speaking, the above definition is acceptable, but for precision, set is defined as a collection of well-defined objects. Let's take an example. Suppose a new teacher is posted to your school to teach mathematics in SS2. He goes to the library to get some textbooks. Below is the librarian response to his question. Mathematics teacher, sir, where can I get SS2 math textbook? Librarian's response. The first one is, you will get some in the mathematics shelves. The second response is, you will get some in shelf 2 of the mathematics shelves. Of course, both responses are correct, but statement 2 is precise. We usually denote set by capital letters, while their members, called elements, by lowercase letters. Our members of any set are usually enclosed in a coiled bracket, and frequently we may write for short, bracket open, x such that x satisfy a certain condition, or x such that x satisfy a certain condition. It's just these two symbols we want to show there, two different symbols used for. Where the signs stroke or double dot means such that. The next definition of term we have here is universal set. This is the mother set from which other subsets emerges or relate. It is denoted by E called E or U. Example, A equals to all the SS3 students of AC College Warren. These students include A, we are now listing the subset, A, all the science students, B, all the social science students, C, all the art students. Let's take another example of universal set. Example 2. A such that X is a set of all workers living in Abuja. Then the subset will include S equals to all civil servants, T also all taxi drivers, V also all private sector workers. Let's go to another terminology, singleton set. These are single element member set. Example, A equals to a set such that A is the principal of Hebrew College, Agbaroton. Example 2, B such that X is the president of Nigeria. You will agree with the assertion that there is only one principal in a college and one president in a country at a given time. The next definition of term, null or empty set. This type of set contains no element. It is the subset of every set. It is denoted by 0 with a stroke or a coiled empty bracket. Let's take some examples. W equals to set Y, set of JSS1 student who is a principal. Of course, that set is an empty set. Note, the set J equals to coil bracket 0 root is not an empty set because 0 is an element. The next definition of term is subsets. This is the child or children of a given universal set. For example, if we have a universal set given as A, B, C, D, E, then the subset under this universal set, some of them could be X equals to A, B, C, and Y equals to A, K, C, D. X is a subset of the universal set. It's denoted by the symbol that is almost like U line down or U with an equal sign. That is, X can be written in a symbolic mathematical sign as S with the symbol of the subset into the universal set. Also, we say that the universal set contains X. That is, we now write the universal set, then with the symbol inverted, then we put X. That is, we say the universal set contains S. That is, with the symbol universal set, then with the first symbol we wrote, we are turning it, then we write the X. It's not a subset of the universal set. And the universal set does not contain Y, which means Y is not a subset of the universal set, and the universal set does not contain Y, respectively. Next, we define another terminology, proper and improper subset. Any universal set is an improper subset of itself. Also, the empty set is an improper subset of all sets, but every other subset originating from the universal set is a proper subset. Next, we define power set. This is the collection of all the subsets of a given set, say S, denoted by 2 raised to power S. Example, list all the subsets of A equals to 1, 2, 3. The power set here is 2 raised to power S, and S here is 3, or the listed element of the set here, 3, which is equals to 2 raised to power 3. And 2 raised to power 3 is equals to 8. That is to say we have 8 subsets. They are listed as empty set, comma, the set with 1, 2, 3, universal set, then a set with 1, a subset with 2, subset with 3, subset with 1 and 2, subset with 1 and 3, subset with 2 and 3. The next terminology we are treating here is equal sets. 2 or more sets are equal if they contain the same elements. Order of arrangement is immaterial. Example, if X is equals to A, B, C, D, Y is equals to B, D, A, C, D, Z is equals to first 4 letters of the alphabet, K is equals to A, B, C, D, E, F, we can say that X is equals to Y. That is, they contain the same element when counted once. Later, D repetition in Y is immaterial. Also, X is equals to Z, but X is not equals to K. Since K contains E and F, which are not element of X. The next terminology is equivalent sets. 2 or more sets are equivalent when they contain equal elements, denoted by the equivalent sign. Example, which of the sets listed below are equivalent? A, 1, 2, 3, 4. B, A, C, D, E. C, A, B, B, E, C, D. A is equivalent to B, since one element of A can pair with only one element of B without remainder. But A and B are not equal. Neither A nor B is equivalent to C. This is so because C has a 6th element which cannot be paired. Though B is equal to C when the elements of C are counted once. Other set notations. We have element of is denoted by the given symbol there. Example, Y equals to the set such that X is between 10 and 15. Then 11 is an element of Y. 12 is an element of Y. And 13 is an element of Y. But any number outside the range is not an element of Y, denoted by the symbol element with stroke. For instance, 30 is not an element of Y. The next notation is cardinality of set. This refers to the number of elements in a given set, say X, and it is denoted by N of bracket open X, bracket close. Example, if X is equals to IJKL, then the cardinality of X is N of X, N of bracket open X equals to 4, which is to say the number of elements inside the given set X is 4, the IJKL, 4 of them. Another example, if B is equals to, the set B is equals to A, B, C, D, E, F, then find N of B. Our solution here, N of B is equals to 6. Let's take another example. Given that T is equals to S such that minus 2 is less than S, less than or equals to 9, where X is an integer, what is N of T? The options are given. Solution, N of T implies the number of elements in the set T. First, we list the members of the set T. T is equals to minus 1, 0, 1, 2, 3, 4, 5, 6, 8, 9. Minus 2 was not included because of the strict inequality there. 9 was included because of the weak inequality there. Thus, N of T is equals to 11. We've come to the end of the first session of terminologies on set. For further studies, you can get the hard copy of the book, Hidden Fact in SSCE Mathematics, at the bookshop, or visit our website, which is listed at the lower part of the screen. Thank you.